Okay, let's look at f of x equals cosecant of x, which we recognize as being the same thing as 1 divided by x. So let's take a look at what the graph's going to do, and just briefly discuss the domain and range. So I'm going to set it up like this. This will be plenty enough to show us the behavior. So you notice I've brought back the -1 and the +1 on the y-axis, and I'm just going to go out to pi and -pi either direction there. So we think, okay, cosecant of x, 1 over the sine of x. So you think, all right, well, the sine of 0 radians was 0, right? We go back to that graph. So at that moment, we're dividing by 0. There's got to be a vertical asymptote here, and it's kind of difficult to draw it on top of my axis, but we can kind of picture that. There's a vertical asymptote happening there. Also at pi, the sine of pi is 0, and -pi. So where the sine of x equals 0, if we're dividing by that, obviously that'll create these 3 vertical asymptotes. Okay, so what happens kind of between these things then? Well, it turns out at pi over 2, if you remember the value of sine, the sine of pi over 2 is 1. So at that moment, cosecant would be 1 over 1. It's going to be right here. And then, I'll just tell you the rest. It's going to curve upwards towards our asymptotes. Upwards in both directions. So it's got that sort of a shape. It almost feels like a parabola or something, but it's definitely not a parabola because it does not extend outwards infinitely far. It just goes right up. And if we were to look back at the negative side, well, it's going to be the same idea except down at -1 and then extending downwards, something like this. So we would say that this whole thing is one cycle or one period of cosecant x. If we were to extend it further in this direction, then we're going to see this alternating, like, you know, down, up, down, you know, kind of in both directions, that same cycle repeating itself. I'll just tell you guys also, knowing the graphs of all of these trigonometric functions, they're helpful just to understand the behavior of the functions, especially sine x and cosine x, that it's got this kind of wave pattern, this periodic nature of something repeating itself. We're not going to deal a whole lot with the graphs of these things, especially when we get into derivatives and that sort of stuff. It's just to understand how these are helpful to model certain types of behavior. Okay, let's take a look at, oh, I put it off the screen. F of x equals secant x, which we recognize is 1 over cosine x. Well, looks like I have a couple of points there already. Same setup as the previous question. Actually, these points aren't even in the right spots. I don't know what I was thinking. Okay, so the graph for secant x is actually going to look quite a bit like cosecant x. It's just going to be shifted, kind of like sine and cosine look very similar, just shifted. For secant x, the vertical asymptotes occur like this at pi over 2 and negative pi over 2. And the graph in the middle would start there at 1 and would then extend upwards in both directions, very much like what we saw a moment ago. And then on the outsides, same idea, but I'm going to draw it like this, because this is how we typically think of. Oh, my mistake. What am I doing? What am I doing? There we go. This is how we typically think of one period of secant x. Instead of drawing the full downward, we think of this half, and that makes one period. It probably seems kind of strange. But you can imagine that, right? So we could complete this and then draw another, and it would do this up, down sort of a thing. Okay, finally, the graph of cotangent x, which we might think of as 1 over the tangent of x, or the reciprocal of tangent x. We could flip this thing and make it cosine of x over sine of x. It's not uncommon to think of cotangent x as cosine of x over sine x if you take a trig class. Okay, so what's this graph going to do? I'm going to set it up the same way we did tangent of x, or close enough, where I don't indicate anything on the y. So this cotangent of x will have a vertical asymptote here at the y-axis, and then it will have another one over at pi, another one back at negative pi, and then it's going to look a lot, quite similar to the shape of tangent, you know, with some kind of adjustment. So this one, it's going to go through, you know, pi over 2 and negative pi over 2, so it's been shifted, and it actually begins up here and then comes down and does this. So it slopes downwards. Instead of tangent goes upwards, right? So I'll draw another one for us, although really just this first graph here we would say is one cycle or one period. No, just to illustrate how it repeats, and of course it would keep repeating in both directions. Okay, so we've seen the graphs of all 6 trig functions. We're going to wrap up this section with one application, and they're going to show us the graph, which is kind of nice. Maybe I can fit this all on the screen. Okay, let's see. It says revenue from sales of a particular beverage are approximated by this function. R of t equals 3 minus 2 cosine pi t over 6, where t is between 0 and 24. And so I'll kind of pause here, and we notice that, yeah, what's inside that cosine? We see pi, you know, pi over 6 even times t. Our t is going to be radians. Anytime we think of one of these functions where it's not uncommon to see pi involved, or something like pi over 6, so we know that t is in radians. When we calculate this whole thing, that'll be a radian measurement of the angle. And it's hinting at, you know, because it's got cosine, it's hinting that the sales from this beverage are cyclical. Like, there are seasons when the sales are up, and then there are seasons when the sales are down. But then, you know, a few months later, the sales are back up. Maybe, you know, if you know, when it's warmer weather, maybe they sell more of these, or whatever this kind of beverage is. I don't know. Obviously, it's something more complicated than just the cosine of x or the cosine of t, right? There's kind of this shifting, and we're subtracting it. And okay, we'll see the graph here in a moment. R is in millions of dollars. That's nice. T is months starting on January 1. So t equals 0 is the beginning of the year, and then 1 month later, 2 months later. Okay, so here's the graph. You guys will not be expected to graph such things. This is provided for us. Or we could always take a look at it in Desmos. So we can kind of see the behavior of how this beverage is selling, right? So in January, the sales are the lowest that they will be. You know, they're at, what, like $1 million or something. A few months later, in April, they've climbed up to 3 million. And by the time July hits, it's at its peak of 5 million. And it's going to kind of do this wave, you know, up and down every year. Yeah, okay. So that makes sense. I mean, that's really helpful that we have such a function, cosine, to help us graph something like that. All right, so what are the questions we're going to get? And I'll just tell you guys the questions that we see here. I mean, I don't like to say such things as a teacher, but I think in this case it's appropriate. Even in your homework, I mean, this is what you're going to get in this section. We're just getting used to these functions. All they're going to do is ask us to calculate certain values. That's it. We'll do more difficult things, you know, derivatives and things later. But for now, we're still just getting used to this idea of them, these trig functions at all, and then the fact that they're functions. And okay, so we're asked to calculate r of 1, and of course, again, I've said it a million times, but you know, the 1 is a radian, so you want to make sure you're in radian mode. So I'll just go ahead and I'll write this out. My pencil's a little bit light today for some reason. Okay, so we're going to put in, you know, 1 for t, I guess, like that. So grab your calculator, be sure in radians, and figure this out. I'm hoping you guys have a pi button in your calculator that you can just click that. If not, you can use 3.14 as pi. Okay, so I'm putting this in. My calculator wants to give me this exact number, so I'm going to hit the double arrow, and here I have it. 1.2679 will be 4 decimal places. And that's all we're looking for. $1.2679 million, if you were to interpret that. And maybe another good question is exactly when, what is R of 1? At what calendar date? And well, 1 would be February 1st, right? So their sales are going up a little bit in February. Okay. Hey, how about R of 6? Well, put in t equals 6, you know, we can just cancel those out, right? 6 over 6. So maybe you just say 3 minus 2 cosine of pi. This one you don't have to round. It's exactly 5. Really confirms, right? 6 is July 1, And in the graph, we could see that that was up at 5 a moment ago. That's their peak revenue. Obviously, the value of t, here we had whole numbers, and you're going to see that in your homework, but we could have, you know, it could have been 5.5 or 6.2 or anything like that. Well, that is the end of 8.2. Gotta say, kind of some shorter sections, and in the end, not nearly as demanding of some of the other stuff that we did back in chapter 7. So that's kind of a nice reprieve here while we get used to what's happening with trigonometry. We'll conclude that here. Check out the homework.